In this video, I'm going to talk about the MPLS explicit tunnel configuration with policy-based routing for forwarding the packet into the tunnel interface. You know that until now we configured the tunnels, and after configuring the tunnels we used the for example static routing for forwarding the traffic inside of the tunnel interface. But here I'm going to talk about the next method for forwarding the packets, the real data, to the tunnels. Look at this scenario. In this scenario, as you can see, we have two tunnels from the router 1 to the router 5. The first tunnel established with explicit method from router 2 and then router 5. After that, we have the second tunnel from R1 to R3, R4, and R5. Okay, you know that when R6 or R7 are sending the traffic to R1, normally R1 should forward the packets according to the routing table. For example, because the higher pass has less bandwidth, has a less metric and higher, for example, preference, the traffic from R6 and R7 normally should forward from the higher pass. But when you are configuring the for example tunnel in R1, we can use different tunnels for forwarding the traffic, for example from R6 and R7. You know that with a static routing we can't configure two policy. For example, when you are configuring a static routing in R1 and configuring IP route, for example quad 5, quad 255, and then tunnel 0 as the outgoing tunnel. This means that all traffic to the destination of quad 5 should forward from the tunnel 0. But we need to forward the traffic of router 6 from for example tunnel 0 and the traffic of router 7 from the tunnel 1. Here we can use policy-based routing. You learn about the PBR in the CCNP routing course. If you want, you can watch my video about the PBR in other courses. And in PBR or policy-based routing, we can configure a policy in R1, and R1 can compare the policy in the we are configuring on this interface, on the input interface. If the traffic is receiving from the R6, we can configure the policy to forward the traffic into the tunnel 0. And if the traffic is received from the router 7, we can configure the PBR to forward the traffic to the router 3. This means that here in this scenario, in this kind of scenarios, we can use the next method, policy-based routing, to forwarding the traffic into the tunnel, for example, interface. Here, I'm not going to configure any new feature about the MPLS traffic engineering tunnel, okay? I'm going to configure the PBR for forwarding the traffic inside to the tunnel. You know that for configuring the tunnel, we have some options: explicit, dynamic, semi-dynamic, but we are using explicit until now, and also in this scenario, I'm going to use explicit. But about the forwarding of traffic into the tunnel interface, we have different methods. The first is for example static routing, and the second is PBR. Here we want to talk about the PBR or policy-based routing for forwarding traffic into the tunnel. Let me to configure this scenario. After that we can talk about more than this about the policy-based routing. The only things that I'm going to talk about that to configure it is that in the PBR, in the policy-based routing, we can use set interface and tunnel number for identifying the tunnel interface. Let me first configuring the scenario. After that, again, we can review the configuration. Okay, we can start the configuration of the MPLS TE multiple explicit tunnel using PBR or policy-based routing. Here we have the scenario we saw in the previous video with a little change in the link between R1, R8, and R9, but other side of the scenario exactly the same with the previous previous scenario. Only we need to change the protocol from ISIS to the OSPF. Let me to use the notepad file of the previous scenario for easier and also faster configuration. First, we can configure the IP addressing and also the OSPF configuration, and also MPLS traffic engineering configuration. Here in R1, we need to configure conft hostname R1. I'm going to only to review the configuration: IPsec, MPLS label range between 100 to 199, and then I enabled MPLS traffic engineering tunnels. It's okay. About the interface ETH00, this interface, we have the IP address of the 10.181 in the previous scenario. We can configure a new range of IP address because here we have, for example, 3 routers, router 1, router 8, and router 9. If you want, we can configure the 10.1, okay, 89, okay, because here we have 8 and 9, 10.1, 89, 1, that's it. 255, 255, 2550, no shutdown. We don't have ISIS in this scenario. We are using the OSPF. Let me to use IP OSPF 1, area 0, that's it. And then we can configure IP RSVP bandwidth on this interface. You know that here the R8 and R9 are, for example, routers outside of the service provider. This is the service provider, for example. In the previous scenario, we used the R8 and R9 as the service provider routers. If you want, you can configure only IP addressing in router R8 and router 9 with one default. But let me to configure also the R8 and R9 as the routers of the service providers. It's not important for in this time for us about the design of the scenario. We are learning the traffic engineering, okay? And then IP RSVP bandwidth, it's okay. And then MPLS traffic engineering tunnels on the ETH00. Very good. Let me to configure ETH01, interface ETH01. In the router 1 here, we don't have interface ETH01. In the previous scenario we had. Let me to remove the interface ETH01 in the router 1. Then about the interface ETH02, we don't have any change. About the IP addressing, we need to configure IP OSPF 1 area 0. And also we need to configure IP OSPF network point. It's not mandatory, but it's recommended. IP OSPF network point. Okay, we don't need ISIS network point. And also we should configure IP RSVP bandwidth and MPLS traffic engineering tunnels on the interface of ETH02. About the ETH02, we don't have any change about the IP addressing, but we need to replace the ISIS configuration with the OSPF configuration. IP OSPF 1 area 0, IP OSPF network point, then IP RSVP, for example, bandwidth, and after that MPLS traffic engineering tunnels. Let me to configure interface ETH10. In interface ETH10, we have the same IP address, but we need to change the ISIS configuration with OSPF configuration, IP RSVP bandwidth, MPLS traffic engineering tunnels. We have interface loopback 0, and here we need to configure the IP OSPF 1 area 0. That's it. And then let me to replace the ISIS configuration with the OSPF configuration. Router OSPF 1. The first command is router ID 192.168.2541. The second command is the MPLS traffic engineering commands, MPLS traffic ENG router ID loopback 0, and then MPLS traffic ENG, okay, area 0. That's it. This is the configuration of the MPLS traffic engineering on the router 1. Let me to copy this part of configuration and pasting on the router 2 instead of the ISIS, and also in the router 3, and after that router 4, okay, and then router 5. This is the router 5, and then router 6, and after that router 7, for example. This is the router 7 configuration, and then for example router 8, and finally the router 9. Also we need to change some parameters such as the router ID in this configuration. In the router 9, I'm going to use the router ID 192.168.2549. In the router 8, the 192.168.2548, router 7, 192.168.2547, router 6, 192.168.2546, and then in router 5, 192.168.2545, for example. In router 4, 192.168.2544, and then in router 3, 192.168.2543, and after that in router 2, 192.168.2542. Okay, this is the OSPF configuration. Let me to continue the configuration of the router 2. Okay, in router 2, about the MPLS configuration, traffic engineering configuration, we don't have any change. We need only to replace the ISIS configuration with OSPF configuration on the interfaces. For example, on the interface ETH00 of router 2, and also interface ETH01 of the router 2. Other configuration are same. Also on the interface loopback 0. That's it. Okay, in all other routers we need to do the same thing. In router 3, again, replacing the ISI's configuration with the OSPF configuration in